Today, we'll be solving LeetCode 20, valid parentheses. This is a classic problem that tests your understanding of stacks and how to handle matching pairs. It's super useful for beginners to master because it shows up in many coding interviews and real-world scenarios where you need to check balanced expressions. So here's the problem: you are given a string S containing just round, square, and curly brackets. You need to determine if the input string is valid. What does valid mean here? Every opening bracket must be closed by the same type of bracket, and the brackets must close in the correct order. Let's go over some examples. The first and second examples are valid. However, the third example is not valid because the closing bracket does not match the last opening bracket. The last example is valid because the brackets close correctly and in the right order. Now, let's think about how to solve this problem. The key insight is that whenever we see an opening bracket, we want to remember it and wait until we see the matching closing bracket. The perfect data structure for this is a stack. You can think of a stack like a pile of plates where you put plates on top, and when you remove one, you always take the top one off first. When we encounter an opening bracket, we'll push it onto the stack. When we find a closing bracket, we'll check the top of the stack to see if it matches the type of bracket that should be closed. If it matches, we pop it off the stack and continue. If it doesn't, or if the stack is empty when we try to pop, the string is invalid. At the end, if our stack is empty, it means every opening bracket found its matching closing bracket in the right order, and we can confidently say the string is valid. Here's the code. I'll explain every line carefully. We start by creating an empty list called stack. This list will act as our stack to keep track of opening brackets as we go through the string. Next, we set up a dictionary called bracket_map that maps each closing bracket to its corresponding opening bracket. This dictionary helps us quickly check matches without writing multiple if statements. Then, we loop through each character in the input string. Inside the loop, we check if the current character is a closing bracket by seeing if it exists in our bracket_map. If it is a closing bracket, we attempt to pop the top element from the stack, but only if the stack is not empty. If the stack is empty, we assign a dummy character like hashtag to indicate there was no matching opening bracket. After popping, we check if the popped element matches the expected opening bracket from our map. If it does not match, we return false immediately, since the string is invalid. If the current character is not a closing bracket, that means it is an opening bracket. In this case, we simply push it onto the stack by appending it to the list. After we finish processing all characters, we check if the stack is empty. If it is, it means all opening brackets had matching closing brackets in the right order, so we return true. If the stack still contains elements, it means some opening brackets were never closed, so we return false. The time complexity of this solution is O(n), where n is the length of the string. This is because we loop through the string once, and stack operations like push and pop happen in constant time. The space complexity is also O(n), in the worst case. This happens if the string contains only opening brackets, and the stack ends up holding all of them. The key takeaway from this problem is understanding how the stack data structure works and why it's perfect for problems involving matching and ordering, such as checking for balanced parentheses. Using a hash map to quickly map closing brackets to their corresponding openings simplifies the code and improves readability. This problem also shows the importance of handling edge cases, like empty strings or strings with unbalanced brackets. The stack pattern used here can be applied to many similar problems, including syntax checking in compilers, expression evaluation, and even validating XML or HTML tags. And that's how you solve LeetCode 20, valid parentheses. I hope you guys found this explanation helpful and clear. Thank you so much for watching, and let's keep learning.